Great morning, Aditya sir.
Very great morning.
You become very
Wonderful
busy
to see
nowadays.
you back.
Aditya ji,
Yes.
very busy nowadays. Anyway, best of luck.
Busy word is, see, after all this learning, busy word is not there. It is maybe preoccupied or enjoying life.
Enjoying life.
From
Yes, you have to
Monday,
enjoy every day, every moment.
Monday morning I went out Vadodara, then Delhi, then Jaipur, then Ahmedabad. Yesterday night I came back. All that for vice president election, this thing.
But take care of health. Eat
Yes.
good food only.
Yeah.
That's all I can tell.
Yes.
You have to be energetic
So let's
every day.
start.
So you have to eat all this.
A very good morning to everyone present. Welcome to Scaling on Saturdays. We have with us today Dr. Alok Shrivastava as our guest speaker. Our platform has been blessed with various coaches, mentors, speakers, social media influencers, founders, gurus, trainers, judges, lawyers, TEDx speakers, as well as consultants. And today we have with us scientist from ISRO, Dr. Alok K. Shrivastava, who is an outstanding scientist and director at U.R. Rao Satellite Center. He has been a gold medalist at graduation level from Government College, Bilaspur. He joined ISRO in April 87 as a thermal design engineer for India's first multi-purpose spacecraft INSET-2A, and after designing more than 10 spacecrafts, including Chandrayaan 1, 2, and 3, Mars orbiter mission, MOM, as project manager, deputy project director, group director, and deputy director. He was a chairman of a standing review committee, the review board for all spacecraft built by ISRO. He was co-member review board of 60 committees in various capacities, with chairman and member. He was co-committee member to address many technical issues as a configuration study team member in UR Rao Satellite Center for evolving new spacecraft. He was also a board member for a few projects in DRDO and Sriharikota Launch Port. He is body member of International Journal of Heat and Mass Transfer and International Journal of Engineering Practical Research. The thermal engineers of ISRO have completed their three thermal engineers of ISRO have completed their PhDs under him and developed three unique technologies for future space applications: PCM coupled heat pipe system, mechanical pumped fluid loop, plasma electrolyte, oxidating coating. So there are 70 R&D activities in the field of thermal structure and mechanics in the progress under him. He has been awarded as ISRO Team Award for Chandrayaan 1 spacecraft, Astronautical Society of India Award for year 2007, ISRO Award for 2016, Executive Secretary for ASI from 2014 to 2020. He has delivered more than 150 technical talks in English as well as Hindi throughout the country in last 25 years. He has published around 35 papers at national and international level and more than 250 restricted internal reports within ISRO. He was member of advisory board for School of Mechanical Engineering, MIT World Peace University, Pune. He did live courage of Indian launches from Sriharikota, the only spacecraft of India for almost 30 launches, including Mars Orbiter mission MOM and Chandrayaan 2 from ISRO Telemetry Tracking and Command Network. With so many feathers on his hat, we welcome you, Sir Alok ji.
Namaste, good morning to all the SOS member. And in another couple of minutes, we will have a small journey. Would like to take you from ground to space and how this mission has been planned and what all the setbacks we had it. So all that we would like to discuss with all of you and share our thoughts and learning. So hope I'm able to show you the presentation.
Yes, sir, visible.
Okay. So once again, I welcome you and thanks to the organization basically for giving me this opportunity for joining all of you and sharing my thoughts and experience. And I'm sure that you will appreciate the efforts put by ISRO, and definitely for the country, it is really a great thing. So let me just quickly start the presentation. So basically, ISRO has commenced its journey from beginning. I'm just sharing and going in the PowerPoint mode. Is it now visible throughout the screen?
Yes, sir, very, very much visible.
Okay, so let me quickly start it.
So is there any sound in the in this?
Yeah,
Sound is not there. You have to reshare the screen with the sound option thing.
there was a slight delay in the sound. Is this still not coming?
No, sir. Have you share take the sound option
Just
in
a
the
moment.
bottom left corner when you share the screen? So please reshare, and in bottom left corner you will get the sound option.
Yeah, I think, yeah, that was the issue. Yeah, now screen is visible, bro?
Yes, sir.
ये सजता संवरता निखरता ये देश, जैसे कोई दुल्हन बदलती हो भेष। ये वादे इरादे कसम ये नई, ये मेहनत मशक्कत ये खुद पे यकीन, यही है सुनहरा सा भारत। हवा में हुनर है, फिजा में महारत, जमी को फलक को हुआ तब गुमान, जमी को फलक को हुआ तब गुमान, लिखा चांद पे हमने जय हिंदुस्तान, लिखा चांद पे हमने जय हिंदुस्तान। लहर है सहर है ये बदलाव की, वतन के जतन से सजे ख्वाब की, जता दो बता दो कि तुम कम नहीं, विजय का लगाना है परचम यही, जहां तुम खड़े हो वहीं हो शुरू, बना दो तुम भारत को सबका गुरु। अमर वो अटल वो अमिट दास्तान, जिसके पन्नों पर लिखा हो जय हिंदुस्तान, जिसके पन्नों पे लिखा हो जय हिंदुस्तान। जय हिंद।
जब जीरो दिया मेरे भारत ने मेरे भारत ने, दुनिया को तब गिनती आई, तारों की भाषा भारत ने, दुनिया को पहले सिखलाई, देता न दशमलव भारत तो यूं चांद पे जाना मुश्किल था। धरती और चांद की दूरी का अंदाजा लगाना मुश्किल था। सभ्यता जहां पहले आई, सभ्यता जहां पहले आई, पहले जन्मी है जहां पे कला। अपना भारत वो भारत है जिसके पीछे संसार चला, संसार चला और आगे बढ़ा, यूं आगे बढ़ा बढ़ता ही गया। भगवान करे ये और बढ़े, बढ़ता ही रहे और फूले फले, बढ़ता ही रहे और फूले फले।
23 August 2023, that was the day when India has written a history. But the journey commenced 21st November 1963 when from Tumba Church, ISRO has launched its first rocket, first sounding rocket. And the vision from father of space science in India, Dr. Vikram Sarabhai, he made a very simple remarks saying that we don't want to compete with anybody globally, but we want to be a hero in our society to attend the last man problem so that the utilization of the space should reach to the last person. The journey was very humble. The beginning was very humble. From 19th April 1975, from Aryabhatta rocket to Chandrayaan 2 and 3 and Mars orbiter mission, what you are seeing the satellite here, and the rocket, sounding rocket taken from the cycle to a very powerful rocket of GSLV Mark III, what you are seeing here. The journey was really remarkable. And why we should have a satellite? A simple answer is, it's a global view from that is height. That's approximately, if I leave the spy satellite, it's approximately 600 to 23,000 to 26,000 to 36,000 kilometers. At that altitude, we try to keep our satellite so that the look of the Earth will be global, a bird eye will be seen there. Actually speaking, the deep space is a very harsh environment, pressure to the tune of 10 to the power minus 12 torr, almost vacuum, and the temperature is almost 4 Kelvin, that is a minus 269 degrees Celsius. And the worst part of that is, in case you would like to leave the Earth's atmosphere, you have to pass through a torus, what we call as a Van Allen belt. You have to pass through the torus of highly energized particle. Like this, many belts are there in deep space, like Van Allen belt, Kuiper belt, and so on. So in case we don't keep any protection appropriately, we lose the satellite. The satellite will be kept into the orbits depending upon the need of the satellite, the application of the satellite to different orbit. We call it a low Earth orbit, medium altitude orbits, or geostationary or geosynchronous orbit. These are the type of orbit where we keep the satellite and meet the country's demand for different application. The ISRO was given the manifesto to have a launch vehicle development, Indian National Satellite Inset Satellite Network for the communication purpose, and Indian Remote Sensing Satellite IRS kind of satellite in the very beginning. India really ISRO has met all its requirement. Like typically, if I say communication satellite, which will be almost 35,786 kilometer altitude from the ground surface for various applications like TV broadcasting, mobile satellite services, VSAT connectivity, data collection, disaster warning and management. Similarly, if we talk about the Indian remote sensing satellite, information to country for infrastructure development, for deforestation, for the flood monitoring, And for so many cartographic application, including oceanography, we use this kind of satellite in our country, and we are self-reliant fully. We have launched more than 110 to 112 satellites as on today, and in our Indian sky, we have 51 satellites in orbit as on today. It was the time in 1947 when India got independence. We used to beg for grains from United States, but today is the day when more than 34 to 35 countries, more than 320 satellites, including United States, ISRO has launched it. And more than 75 launch vehicles, ISRO has already successfully launched it. It was the time when the global coverage was to the tune of 1 pixel equal to almost 1 kilometer. It means that from the ground, 1 kilometer by 1 kilometer resolution, we used to take picture. But as on today, even anything which is almost 23 centimeter, 0.23 meters, we can easily capture it and utilize it for our application. And this is the great achievement in the form of Indian remote sensing satellite. When it comes to for the weather forecasting, there was the day when very high resolution radiometer VHRR used to be there. Compared to that, we never used to have a very good prediction. In fact, media used to comment that when ISRO is predicting that today rain will be there, please don't take umbrella. But today is the day when our advanced meteorological satellite like INSAT 3D and 3DR, not only for very good weather prediction, as well as saving the billions of property and millions of life across the globe. We are helping and also monitoring the pollution control in terms of the aerosol, optical depth particles. The particulate matter will be approximately 2.5 to PM 10, which is very easily can be monitored like cities like Delhi and Haryana. In fact, this is the type of the satellite will be there. Satellite will be continuously monitoring only single trace, but because Earth rotates, like that entire Earth will be covered. Typically, let me say that one hurricane or one cyclone is to be monitored. Actually, this we have a typical payload, not like VHRR, very high resolution radiometer, but we have a imager and sounder. Imaging is the term which is utilized for the purpose of taking picture horizontally. But along with horizontal imaging, we have a vertical imaging also. So there we can take the picture in the vertical direction, and that's how when cloud not only moves, but also goes up in the sky, we will be able to give very good prediction for that. And we have excellent mathematical model of entire atmosphere, including the Earth, and do the prediction by using the high power computational system. This is the satellite evolution of weather forecasting over 3 to 5 decades in India. And I was project director for INSAT 3DR and 3DS were successfully launched, and we have really contributed and able to predict it. Now we have 2 satellites already, INSAT 3D and 3DR in space. INSAT 3DS, any moment, any month, it will be ready to launch, to replace or to work together. You can say that one satellite takes almost 26 to 30 minutes to process the data. But if the 2 satellites are there, every 15 minutes we can get the data, and we can monitor the cyclone or birth of the honeycomb and hurricane, and how this eye is moving in what direction, with what speed, and when it is going to strike the shore. Easily we can predict it. And this is how weather forecasting is done. And with the combination of the high altitude communication satellite and low altitude Earth observation satellite, including the upcoming medium Earth observation satellite, we will be able to monitor and continuously monitor and do the disaster management in the case of like Chennai flood is there, or any kind of landslide is there where ground support is not possible. From the space, we will be able to manage very well. As for coming to GPS systems, like Americans have, and GLONASS for the Russians, and Galileo European, and Compass for the Chinese. These are the global geopositioning system. It has got vast application, including very recently when a war is going on between Israel and Gaza. You can see that this has been utilized very well. ISRO has regional satellite services called Navi constellation of the constellation of 7 satellites. 4 satellite is synchronous. That's what you are seeing in orange color in the orbit, and 3 in the blue. So 7 satellite constellation can give us a better than 20 meter accuracy to do the prediction. This is very, very essential for our the defense purposes. Along with all these applications, the quest for the knowledge and monitoring the space for once upon a time atmospheric event happening like gamma ray burst and so on. If we don't have a space lab like AstroSat India has got very advanced stage, we will not be able to do the X-ray astronomy, and we will not be able to monitor such events and find it out, the black holes and so on. So in case we need to do that, we need to have such missions where the quest for the knowledge, the origin of life, deep understanding of our planet, all this need can be very easily met for the space platforms. And after getting the data sharing with the globally and getting the better information. This started with 1963, and as on today, we have so many scientific satellites, including Chandrayaan orbiter missions, and then AstroSat. Then we have Mars orbiter mission, which is recently completed the life, and we had a SoS satellite. So we had so many, and very shortly we are going to launch X-ray polarimetry satellite called XPOSat in space. As far as the satellite is concerned, we have now almost got full confidence about the building of the satellite, building of the scientific instrument, getting the data dissemination, and providing necessary information. Now we are not at all bothered about the getting the data from outer world, but the war-like situation like Kargil, if it happens, we are self-reliant, because at the time of Kargil, India was denied the support of the such data from United States. Similarly, coming to the launch vehicle, we started from almost 17-ton rocket, which can carry 40 kg satellite. We are now almost 3,500 kg satellite. We can lift up by almost 420-ton rocket of a GSLV. And we have a very successful satellite series, rocket series called Polar Satellite Launching Vehicle, PSLV. This is also very powerful rocket, and this is the rocket which gave us the support for the Chandrayaan-1. After getting complete information about the application of the various kinds of satellite ISRO has developed, then we started feeling, are we alone? Where did we come from? What is our destiny? And moon has fascinated man by eons. So then question arises that what all we can do towards that.
There has been no civilization on Earth untouched by beliefs surrounding the moon. The moon has been an object of wonder and amazement for the common man over the centuries. At the same time, the scientists have been busy unraveling the mystery of the moon. It has been the source of many queries. Even today, the quest of the moon continues. The study of the moon has continued over the centuries. But then, reaching the moon was the real dream of mankind.
T-minus 15 seconds. Guidance is in trouble.
But even today, after more than 50 lunar exploratory missions, we still have many unresolved queries. How could Earth acquire such a large satellite? What is the Moon's origin? What is the Moon's chemical composition? Do we need to know these? Then again, the study of the Moon for the effects of the interplanetary processes can provide us the understanding of the physical environment of the ancient Earth. This is possible because similar interplanetary processes must have affected both the Earth and the Moon. This proximity also brings out the mystery of the origin of the Moon. Is it a body formed elsewhere in space and captured by the Earth in one of their close encounters? Or is it formed from the same cloud of dust and gas out of which Earth formed in the beginning, side by side? Or was it an outcome of a collision of a giant cosmic impactor on the Earth? Many other theories too are coming up. But what is the truth?
In case the truth has to be looked at it, we must have to accept that, my friends, we were so close to Earth once upon a time, but almost 3.8 centimeter per year it is receding away from us. And today it is sitting almost 3,84,000 kilometers. And in case we would like to send a signal from the Earth to Moon, it takes one way takes roughly 1.5 seconds. And if we're coming back from there is another 1.5 seconds. So each second, like 3-second journey becomes very, very crucial. That's why Chandrayaan 2 and Chandrayaan 3, we wanted to do the maneuver. Why that's very important. This is what I wanted to mention it. It all started with the Cold War between the two countries like USSR and United States when USSR launched Luna series in 1959 and Apollo series by United States was going on one after another. But suddenly, abruptly, 1976, both these countries suspends their lunar mission. This is the same Luna series. Just before of Chandrayaan 3, Luna 25 was launched and it got crashed just before our Chandrayaan 3. You would like to recall that. Unless and until 1994, with Clementine and Lunar Prospector mission in 1998, United States confirmed that there is a possibility of water molecules available on the lunar poles, and the request was revived from then onwards. And today, as when we discuss globally, more than 200 reasons are there why we need to go to the moon globally. Understanding the difference of evolution, laboratory for natural station for future exploration, and landing site near the equators were very common. I'll show you, but the poles were untouched. Adequate global and local topography of the lunar gravitational model is also not known. So you just try to understand this is the nearest galactic body to us, but we don't have excellent magnetic model. We don't have gravitational model of the Moon. In fact, many a times people call it that you might have seen that lunar as having hollow body inside. But all this can be answered in case we would like to have several missions like that. Image coverage is still limited. Spectral information is inadequate. Today we are having much better information about far away planets rather than nearest galactic body Moon. So insufficient data, chemical composition is not yet known, and training and future is business ventures. All this will become very, very important. As and today, many of the countries, they join hands together to reach such missions, to arrive at, to finally conclude towards these missions. So human civilization, global partnership, exploration, preparation, resume mapping, resource mapping and space tourism. In fact, for your information, even in Chandrayaan, one time itself, ISRO has done, India has done a large collaboration with the spacefaring nations. This is what I was mentioning to you just now. This red dot on the moon that shows that previous missions were very close to equator, but North and South Pole, they are untouched. You may ask that, you may think that, what is so special about the pole? Yes, the pole is very, very important. Typically, for example, South Pole, where ISRO has launched the mission, you can see the center picture at the bottom. We can say the blue patches, blues, small circles there. They are expected at South Pole Atkin Basin. Very big crater is there, where we are expecting that water molecules will be available in the solid form. Remember this I'm going to talk little later, that why that is not available like a drinking form water as it is available on the earth, because the temperature is very, very low on the rear side. Any temperature will below -90, -90, -100 degree, straight away it goes from solid to gaseous form rather than the liquid form. So we want to have the physical property of the moon, the chemistry of the moon, nature of the lunar crust. There were topography available information, gravity, magnetic, which I talked about. Also, the radiation environment is definitely not available for this body. That's why we wanted to go there. So Chandrayaan series has started. Chandrayaan-1 satellite, this is how it looks like. There, my dear friends, this is the only satellite which is globally having almost 11 scientific instruments on board single satellite. No satellite globally is available. And in this satellite, we had so many instruments. The top, whatever XSM you are looking side by that, there is a MIP, Moon Impact Probe. This is the instrument which got separated. I'll show you in the video. And this got separated from the lunar orbiter Chandrayaan-1 and fell down exactly at the same time, same trajectory what India has expected right in 2008 November itself. So we had a good experience of this hard landing, but we wanted to go for the soft landing. So different countries, they came together, and October 2008, we have launched Chandrayaan-1. So we had a collaboration with the NASA, JPL, then Brown University's Rutherford Lab, Max Planck Institute from European Space Agency, JAXA Japan, IRF Sweden. So many scientific communities, they came together to give their scientific instrument to get a place in Chandrayaan-1, and we have launched this satellite. There are three approaches how we reach to any such galactic body. One is if you have very powerful rocket like NASA has, USSR has, or China has, they can direct transfer to moon, so they can take less time and they can go after us, reach before us. This is what Luna 25 did it. So they can inject the satellite at certain altitude and directly with such a high velocity, and directly can go and capture the planet wherever we want. That is the first approach. Second approach, what sometimes European Space Agency and NASA follows, we call it the weak stability boundary transfer. Here what happens is you launch any satellite, automatically we know that it's going to come back to Earth, but definitely with a different trajectory. In that condition, you want, if any other galactic body is coming on its way, you can capture it. So you don't require any extra power, any fuel, any energy, and you can still go and capture another body. Third is what ISRO follows in the bottom one, incremental efforts for better results. So every time we inject the satellite at almost like, you can see there is a blue circle that is simulating Earth, and around that 220 kilometers we launch the satellite in geostationary transfer orbit, we call as a GTO, and slowly every ellipse at nearest point we call as a perigee, we fire the built-in engine in the satellite, and we can increase the orbit. So like that we can go on increasing the orbit, and there will be a large orbit called lunar transfer trajectory. At that time, moon also will be coming closer. And that this is very important for you to understand when I'm going to show you the video. So when it is coming very close to moon, at that time there will be one point, it is a moon, it's Mars or anybody, where the gravitational effect of the or attraction force between the two galactic bodies will nullify. Exactly at that point, we issue the command from the ground and change its orbit, and this is how we capture it. And after that, instead of increasing the orbit, we can reduce the orbit and go for that. For getting the signal from such altitude, we have a large antenna. Chandrayaan, one time we had a 18-meter antenna, what we call as the Indian Deep Space Network, to 32-meter terminal during the Mars orbiter mission time, and later on Chandrayaan 2 and Chandrayaan 3. For your just information, that as on today, the largest antenna is available, almost 76-meter diameter antenna is available in the JPL Pasadena. And in fact, that's why when any feeble, any weakest signal also, if it is there, they try to get it and communicate.
TMC will take three-dimensional black and white imagery of the lunar surface with a resolution of about 5 meters.
One of the instrument out of the 11 we call as a hex. That is basically getting the reflection or emitting the X-ray from the satellite and then getting reflection. So you can say that we are getting very good resolution and very good images we are getting. Similarly, like
HiSci will rely on the visible and near-infrared rays reflected from the moon and will slice the incoming light into 64 parts to observe many specific details.
5 meter. We get it, and each and every band has very special information about the surface texture of the moon. And you may think that because Chandrayaan 3 has a very special finding this time, which is an invention which none of the country, including NASA, ESA, and USSR, Glaucosmos, nobody got it. For the first time, it is the declaration that we have a sulfur content in the moon's crust. And how will we do that? Sun's energy falls on the lunar surface. Either it can be reflected or it can be emanated from there, that surface. And these fluorescent X-rays or reflected X-rays will be captured by the satellite. For every element which is available on Earth, we have a standard spectrum which is available, and that spectrum will be compared. And this is how we predict that we are having calcium here, iron here, thorium here, potassium here, sulfur here. This spectrum is available. This knowledge is available with us. So based on the scientific instrument spectrum information, we compare and we communicate. This is how we do that. My dear friends, it was the first opportunity for ISRO to do that. And we should never get lost. You know, when first time is Chandrayaan 1 was given, and I was the thermal designer for that. And you will be shocked and surprised to know that moon is as hot as the sun is. So many of the missions, almost 54% of the global missions, failed because of the thermal. And that time, our chairman has told that we must ensure that there should not be any failure for the moon mission for satellite. You are seeing the left picture. From the front surface, the red dot shows, as we call as the subsolar point. There we see that temperature is almost 123 degrees Celsius, and temperature we keep on reducing adjacent and goes to poles where temperature will be -70 to -90 degree. And the right side picture exactly opposite, we call as the near side of the moon and far side of the moon. So we touch almost -170 degrees Celsius. If you are on Earth, you will not be able to see the far side of the moon and complete picture. We have to leave the Earth to get that picture. Now we have complete information of the satellite. For launching the Chandrayaan 1, we need a PSLV rocket. So how the rocket is built? We can see that it was first effort. We did not have any information how to design the satellite. We had a very good experience of communication satellite, remote sensing, right? But we were having a moon to mission. No, we did not have. So we wanted to have that first information, and that was our breakthrough. You can see that this is a 4-stage rocket. First stage is getting assembled here, called solid stage of PSLV, and the side ones are called boosters. So 6 boosters are added to the core, and the PL is hydroxyl terminated polybutadiene, HTPB. It's like a Diwali cracker. So once you ignite it, it will simply uncontrolled way until the fuel is burned. It will lift the satellite and go to the Then the second stage, which is a liquid, which is a monomethyl hydrazine and nitrogen tetroxide, and large, and third is solid, fourth is liquid. Now rocket will be assembled, and similarly satellite is fully assembled and it is tested in our lab. This is the moon impact probe box what I was talking about. It is fully ready and getting assembled in the Chandrayaan 1. After complete assembly and testing in the clean room environment in Bangalore, India. So he filled the fuel. Now he is connecting and we are keeping the fuel in the satellite out also. That is monomethyl.
So sorry to interrupt you.
Yeah.
Can you please mute music? Is too loud.
Oh, I cannot
We
do
cannot
that.
hear you. Yeah.
No, I cannot do that. You can reduce the volume because so now the
You
satellite
can
is-
reduce the volume of the music.
Let me just try.
Yes, sir. Okay now.
So you can see that it was launched, and when it was, I think you missed that. Okay, so when it was coming closer, that moon impact probe box, you can see that how the closer view of the moon when it was landing, how it was appearing. So this is how the moon surface looks like it. We had a successfully launch of the Chandrayaan 1, and we had excellent data from this particular satellite. But after hard landing of the moon, now question came is we should plan for a soft landing on the moon. So we will land on the moon and do the lot of scientific experiment. So here we can see that we had a one module like Chandrayaan 1 as an orbiter and another module as a lander. So there were two models, then they will join together, and within the lander we have a rover also. So we can see that this composite model now become heavy, so PSLV cannot launch. So we have gone for the GSLV. Only thing is that time USSR has planned to give us the rocket, the lander and rover, but they denied this technology. And when they denied this technology, our effort was now to design, develop, realize, test it, and make it ready for the satellite. It was very time consuming. It's going to take a lot of time. In that scenario, India cannot wait for that. So India planned for Mars orbiter mission till this activity was going on. And Mars orbiter mission was between Chandrayaan and Chandrayaan 2. And this satellite was launched in 2014 successfully. This is the maiden flight. Nobody in the world other than ISRO and India who has launched the satellite on the Mars without this. And we had a very big understanding. You can see that the first lesson which we learned in these missions were never copy anybody. Don't copy anybody because it's not going to fetch any breakthrough or any individual knowledge from your mission. For example, if this gentleman, you might have seen this kind of videos, this gentleman is trying to cross the road and the traffic is very heavy. So when he's trying to cross the road, he's not finding a way out. But suddenly he saw that there is a way how to cross the road. And he just tried to copy it. And this is what I told, that never try to copy anybody for any of your objective, any of your missions. So he also tries to follow the same path and tries to cross the road using the same philosophy. And ISRO never does that. ISRO never copies anybody. So when he tries to copy, he fails miserably. Similarly, if you just look at it, what happens is
the one who gets
there
grapes.
was a lot
The one who
of
gets cucumber. Note that the
experiments were
first piece of
conducted.
cucumber
ISRO
is
doesn't
perfectly
have
fine.
any
The first
disparity.
piece he eats.
Young scientists or
then
senior
she sees the other
scientists
one getting grape. And
both
you'll see
have
what
the
happens.
same voice in ISRO.
So she gives
There
a
are
rock
two
to us, that's
monkeys.
the task.
One has been given
And we
cucumber,
give her a piece
another
of
monkey
cucumber and
has
she
been
eats it.
given
The other one needs to
grapes.
give a rock to us.
Unless until both are knowing
That's
that
what
what
she
is
does.
being given and disparity
And
is
she
not
gets a
created,
grape.
it is fine. But when other sees
And she
that
eats it. The
other
other one
fellow is
sees
given
that.
grape, I'm
She
giving
gives a rock to
a
us.
cucumber,
Now,
he
yes, she gets a
returns it.
cucumber.
No, I also want grape. No, this I don't want. Please take it back. And this is the disparity what ISRO does not have. We have equal bias from young, middle level, top level scientists. They sit in the same meeting and do the thing. The third lesson, which is very, very important for all of us, is basically quality.
Is to embrace, integrate, and entrench quality in all phases of our project
as far as
lifecycle.
the quality is concerned.
Engines throttling up, 3 engines now at 104%. Challenger, go with throttle up. Looking very carefully at the situation. Obviously a major malfunction.
Nancy and I are pained to the core with the tragedy of the shuttle Challenger. This is truly a national loss.
Remember that quality was broken and ISRO never compromised with the quality, because the moment quality is compromised, we cannot ensure the product's outcome. You can see that there are so many systems and in ISRO, which is spread across the country with so many subsystems, scientific instrument, there is an excellent support for the communication, the teamwork, which brings them together. So we have got very good mechanisms for the review, for the advice from the senior scientists, and they support us. That's very much required, and specific knowledge from the seniors and experts that comes along with ISRO for any particular mission. Another important thing which becomes very, very essential is unexpected will be expected, that this can happen. Based on that, we have a plan A, plan B, plan C for the future. And that's how that with the teamwork, with the excellent expertise by the support from seniors and the excellent design and the teamwork, we can cross the hurdles which we come across. We never do the blame game. With the teamwork also, we try to achieve the target based on our requirement. The very important, essential finding was the communication gap. How the customer explained in the first one, and how the analyst designed it, how the project understood it, what was delivered, and what customer really needed it. So there should not be any communication gap when you are trying to keep your ideas spread among the teamwork. That's very, very essential, and ISRO believes in that. This is the Mars orbiter mission, which was kept thus ready, and how it has launched in 2013 with the satellite. This is how I was covering the launch of Chandrayaan 1 in the Delhi Doordarshan. And Prime Minister that time, he came with us for launching that. So remember, ISRO believes, though many countries, they try to push us back, we never say, don't, we will believe in don't quit, but do it. So that's very, very essential. In case you want to achieve something unique, it should be done. Now, by the time Mars was getting ready and launched, our Chandrayaan-2 lander and rover design was fully ready. This is how the it is split into two. One was the lander and rover, and other was the orbiter module, which will orbit like a Chandrayaan-1. This is the lander. In this lander, there is a one petal, there is a rover kept inside the lander. This is how the six-wheeled rover, which was built as a Pragyan rover and Vikram lander. And the planned strategy was thoroughly designed, analyzed, and planned and experimented at the ground. All the testing has been done thoroughly, and the satellite was kept ready. This is the orbiter, and this is the lander. Lander is now fully kept ready. Everything has been tested it, and they brought at the launch pad where the rocket is assembled, GSLV for the first time. It is composite model is assembled. And after that, the composite satellite was shifted to the rocket topmost portion, and the conical portion of the rocket, what we call as a payload fairing, was closed, and the satellite is fully ready to lift off by GSLV-3. Here we are having satellite rocket with the solid state side by core, whatever you are seeing. Then central is liquid, and top gray portion, what you call it, it's a cryogenic engine. This is the same cryogenic engine which earlier USSR and USA both denied this technology. But ISRO, based on its human treasure, we have successfully designed and reached it. This is how at the vehicle assembly building, rocket was assembled and shifted to the launch pad. And after launching the satellite, you can see I have already explained to you, first increase the orbit, then reduce the orbit and gone ahead. This is how the Chandrayaan-2 was launched, and the satellite was kept in the rocket.
8, 7,
GSLV Mark 3.
4, 3, 2, 1. We have ignition.
So two side solid stage will be separated. Yeah, it got separated as 200. Then liquid stage will be separated. Now L110 liquid stage from the GSLV got separated. Before that, payload fairing got opened, and the composite Chandrayaan-2 and Chandrayaan-3 kind of satellites, they got exposed. Second stage got separated, and now cryogenic stage, it is going into deep space for its journey to inject the satellite, and then composite model of Chandrayaan-2 or similar way Chandrayaan-3 was injected. Solar panel got deployed, and now we are going to increase the orbit. The way I have already explained to you, now orbit is continuously increasing because we have to capture the moon. We cannot directly, we don't have that powerful rocket, and we cannot directly throw the rocket into such an altitude with such a velocity whether it can capture the galactic body. So we are continuously increasing the orbit. Now you can say the orbital plane also got altered. By that time, moon is also coming now closer, and there is a point we call lunar orbit insertion, and we have captured it. Now we have to separate orbital or propulsion module with the satellite lander, and this is the point where now we are going to fire the engine, reduce the orbit. Instead of increasing the orbit, so we are reducing the orbit. And at an altitude of 100 kilometers, now we are separating. So orbital module and lander got separated. Once they separated, orbital of Chandrayaan-2 continued its data provision to us from that time onwards to now. Lander is coming closer to moon. Very accurate calculations. This is where Luna got miserably failed. They miscalculated and they crash landed. And all this data we were getting from our Chandrayaan-2 MOX, we call it ISRO telemetry and tracking station at Bangalore. We were continuously getting the data. When it was doing it, you can say that orbital was continuously getting lot of images of the moon and ensuring that camera, whatever it is capturing, it is comparing whether I can land here, whether I can land there. And once it gets the right picture and compare the model, it is ready to reorient and go to land. This is how Chandrayaan-2 happened. But just 2.3 kilometers above, we lost the contact. But in Chandrayaan-3, successfully we have landed. But in Chandrayaan-2 time, you can see left side and right side image. This is before crash, and right side, those dots you are seeing, there we have the crash landing. Then our Prime Minister came and they have supported us and told that sky is no longer the limit. But Chandrayaan-2 gave us confidence, gave us enormous data. We did not depend upon NASA, like lunar prospector I was telling. So far, entire world depends upon their satellite, but now entire world depends upon Chandrayaan-2 and Chandrayaan-3 data. This is the achievement of us. You see how powerful digital elevation model of Chandrayaan-2. From Chandrayaan-2, we got it for Chandrayaan-3 landing. A roadmap was prepared for Chandrayaan-3. And in this complete, our objective was safe and soft landing. Lander model was prepared. I'll not go into detail. And thorough testing was done. More fuel was put. Larger area was identified. And this is where you can see bottom right side edge I am standing. Thoroughly testing of lander was done. In case boulder comes, soft land comes, rocky comes, inclined surface comes, everything has been thoroughly tested. And how once we land it, how the rover will be coming out of that. So all this by separate ground command, all this was done. And for this, complete data was coming from the lander and rover to Chandrayaan-2 and to ground also in S-band and KU band. So this is how. Now I'll go to that bottom. Near the South Pole Baglaski point where we have planned to land it, which later on named by our Prime Minister at Shiv Shakti Point. So the landing site was very, very close to Chandrayaan-2 landing site, 70.9 degree latitude. We have landed into 32 degree latitude, 30 degree latitude. So also, in case we cannot land it, we have planned alternate site also. And in Chandrayaan-3, this is what has happened. I'll take only a few minutes more. So here, how finally it happened in Chandrayaan-3. So Chandrayaan-2, we could not land it, but 10, it has given us a lot of information.
8, 7,
this
6,
is the real video
5,
of Chandrayaan-3
4,
launch.
3, 2, 1, 0. Plus 5 seconds.
Lift off normal. P1 tracking.
R2 tracking.
P2 tracking. Stage performance normal. P4 tracking. L1 turn stage ignited.
Plus 2 minutes.
L1 turn stage performance normal. Stages are separated.
So like that, where stages get separated, it was injected to the orbit, and later on it was to be injected in the moon's orbit. So that light reached very close. This is the video taken by Chandrayaan-3. So before landing, this is the closer view of the moon. You can see that whatever Chandrayaan-2 gave the information, it was stored in Chandrayaan-3. And we have compared whether we are on the right track or not. And lastly, I will go to this point where it was, you can see that there are 3 zones. Now, this is the last few minutes. Power descent was the first stage. We were almost 745 kilometers away from the landing site at altitude of 30 kilometers. And velocity was very high, horizontal velocity. So our effort in this particular phase, rough braking phase, was kill the velocity so that almost we should be able to slowly land it. So almost for 690 seconds we did this. Then after successfully reaching this, we have done the attitude hold for 10 seconds, looked here and there, did the lunar view perfectly, lander where our land site is to be there, where landing should be there, any boulder is there, any crater is there. When nothing is there, now we are going to go to the last phase, the final, and then we have shown that if everything goes wrong, compare with Chandrayaan 2 provided the data, then we should be in a position to land it. So vertically, we have taken final picture of the landing. When everything goes perfectly, now we are going to land on the moon's surface. So this is how finally we landed on the moon's surface. So this is what at the last moment what you in the video. This is how our Prime Minister has supported us during that time of the landing. And this is how later on lander and rover came out from the lander, taken the picture of the lander and sent the data, and also did a lot of experiment. And all this has happened because the rover came out of the lander. So only mission was for 14 Earth days. That is one moon day. So it is traversed almost distance of before the moon has evening or night. You can see the line. It traveled almost 100 meters and then slept it. And we never woke up and completed its mission life of 14 Earth day, which is equal to one moon day. Thank you so much for patient hearing. I hope that the journey of our all these Chandrayaan series satellites and the rocket I have shown to you, and what we learned from there, and what are the findings I have explained to you. Thank you so much.
Thank you, sir, for a wonderful presentation. We would have never seen these images elsewhere. So very grateful to you for presenting it and giving such wonderful lessons on quality control, teamwork, communication gap, and the most important one, if you believe it, do it anyhow with whatever it takes. So it was a wonderful presentation from your side. And I would like to ask you a few questions that are arousing in my mind, as well as some of them have been put up by our audience. So we can take some questions from the chat box itself.
Yeah, please.
Why do moon has variable gravity? How it happens?
Yeah, in fact,
question asked by Atulji.
Yeah, it's very, very important. In fact, you know that the gravity is for any galactic body is driven by the mantle core. And this is what I have already explained in my presentation also, that the core of Earth is very, very systematic and very similar from North Pole to South Pole. So that creates the gravitational effect and magnetic effect around the galactic body. But in the moon, how this core is there, that's why NASA is still in the last week, still they have declared that a moon is a hollow body, like a gong. And when any body impacts on it, it vibrates for quite some time. In Chandrayaan 3, because time was not there, otherwise I would have shown that we carried one seismic experiment. So anytime, any small vibration, if it is there on the moon surface, it can be captured. So how this core is there on moon, we are not knowing. And because this core is dissimilar, unknown, variable, that's why the model and gravity and magnetic field also is a variable there.
Thank you, sir. Another question is, were there any humans there in the rocket? I hope so, not so.
No, I as a space scientist, I don't believe that, though many people say that one of the astronauts in one of the Apollo missions say that once they landed there, they saw aliens on the other side doing a lot of mining in the crater, but I don't believe in all that. There is no aliens, there is no human life there. What are the findings of the chemical elements like calcium, iron, magnesium, and uranium, and helium? All has come out, and for the first time, sulfur content also has been found. That's why the upper crust of the lunar surface is little more dissimilar and very rough and has lot of insulating property.
Thank you. Another question that comes is how many total team members were associated with the project? Real numbers, C. Manisha wants to know.
That's really, thank you for asking that query. In fact, I'll tell you, I mentioned that as a teamwork, but almost you can say entire ISRO for this mission was approximately 7,000 to 7,500 engineers. They worked relentlessly, very carefully for the design, development, realization, testing, mission, flight dynamics, and after that, taking to the moon and doing the control guide loop system effectively to land on the moon surface.
Great to know that. And what are the pros and cons of AI in the space research?
Oh, that's a super question. Thank you so much for asking such a brilliant question. I'll tell you, when we wanted to land it, that time I mentioned to you that one-way communication time is 1.5 seconds. So it takes 3 seconds. 3 seconds, you can say that 7 kilometers per second will be the velocity when we inject the satellite. And when it was going on the moon surface, the velocity was almost 1.68 kilometers per second. So if 3 seconds is the time, then we will not be able to exactly land where we want to land it. So we used artificial intelligence to monitor and to build the machine learning in our system, develop the algorithms, trained our hardware in such a way that automatically after that power descent phase and then aero braking phase, I have shown 3 phases. Everything was AI based systems on board Chandrayaan 3 and Chandrayaan 2, and that only made the soft and safe landing. So AI has played remarkable job, whether it is for the temperature control, whether it's for power control, for battery charging, everything was AI based.
Great to know that, sir. And how much space debris is going to affect our environment?
Though it is not directly connected here, but I'll just try to answer. It's a very big issue in the spacefaring community as on today. Globally, many countries, they are coming join hand together and trying to solve the problem of space debris. And as on today, it's a very big issue, very big issue, and it's like a space pollution. And many times you hear the statement that launch is delayed by few seconds. The one of the reason is on its path, some of the debris will be coming, and these debris are being monitored globally by all space agencies. And depending upon the debris size, we try to monitor. And if it is going to, because velocity will be very high, so impact of that energy into the satellite, many of the satellites, we have lost it because of the debris. So we have a very big threat on the space debris, but globally, space debris management is being done by globally by various space agencies successfully as on today.
Thank you, sir, for adding this. And one more question is, how can CA community contribute to ISRO?
Oh yeah, I think you sent me the participants. Today my talk was purely concentrated on the technical being a moon mission. So yeah, CA community is something very special for us. And you know, any of the scientific community as well as our financial human resources, that's also very essential. Entire budget is being monitored, developed by financial experts, including CAs in our organization, and they guide us. They tell us that this is how you should try to control. This is how you can do the monitoring, so that because the budget for the satellite is approximately 169 to 250 crore, as well as if it is a composite, around 300 crores, and the rocket cost will be around 300 to 500 crores. So one single mission, such a large budget, unless and until CA does the proper control of this entire finance aspect, we people in the science and engineering cannot do that, because we concentrate only technically. But there should be some control, some auditing about our financial control. Otherwise, everything will go in heavy. So their job is terrific and their support is great. I hats off to all CA community in our organization also and in country. Thank you.
Thank you, sir. One last question. How does ISRO balance the pursuit of ambitious missions with responsible financial management, and what financial benchmarks or metrics are considered for success?
Yeah, I think in the very beginning, when I mentioned to you 1963 onwards, when we started the ISRO, that time budget was also not very high. Missions were also not very ambitious and not very big missions, only communication, remote sensing satellite. But as ISRO grown, almost you can say, you try to recall when 2 rupees note Aryabhatta picture was there and 2000 note mom picture was there. So in layman's language, we can say that 1000 times ISRO has grown. So 1000 times when ISRO has grown, its budget also has grown so much. Of course, it is not as high as NASA's budget. Our budget is very close to, you can say, one automobile company of the United States. But with that also, ISRO is trying to achieve whatever goal is set. So unless and until this financial things is being controlled, because government can only provide the fund. But when politicians, when the ministers, they ask some query related to that, all our engineers, all our scientists, they have no option but to keep mum. So there comes our CAs, our financial experts, they come forward and they prepare the audit report. They do the support and they answer all such queries. And in coming days, their responsibility will be, if not more, at least equal to all engineers and scientists in this kind of missions. Thank you.
Thank you, sir. If you have a little time, we can take some queries from the chat box as well.
Yeah, please.
Okay, sir. Manisha is asking, sir, kindly relate the budgeted cost of project. Was it as per our expectation?
Yeah, I think I mentioned to you, for example, Chandrayaan was around 169 crore rupees. And because it became a lander and rover in Chandrayaan 2 and Chandrayaan 3, budget was almost 350 crore. Plus the satellite, rocket cost is around 500 crore plus. So together, this will be the kind of budget. But remember, it is a whole satellite and rocket cost. I was working jointly very closely with NASA and other space agencies. One instrument on board Chandrayaan-1 cost was equal to the entire satellite of our Chandrayaan-1. So you can say, for example, people quote this very well, that Gravity movie cost was around 750 crores. And one of our entire mission cost was around well within 500 crores. So Hollywood movie compared to them, our cost is nothing.
Definitely, sir. Thank you so much for elaborating on this. Nareen ji is asking, if countries are joining hands, why does India have to do research from scratch? And is it true China is trying to capture parts of moon, making it their country?
Yeah, very true. This question I faced every time when I go to deliver a talk. If somebody has done graduation, post-graduation, doctorate, that does not mean that I also should not do that. or I am not entitled if somebody does their graduation or any kind of degree? That's the first question. So unless and until we have the first-hand information, nobody is going to give the right information to right time. When Kargil war happened, they did not give, NASA did not give any information about our boundary surveillance. Then what do? We launched a TES satellite, and around our boundary surveillance, we got the data. And when you say that why we do from scratch, we should have in ISRO, why ISRO succeeded, we call it the ABCD formula for success of ISRO. Autonomy, we are away from the bureaucracy, excellent communication, and D is for democracy. So ABCD formula of that is basically we have a fundamental knowledge of every science that we are, what is involved in the rocket and involved in the satellite making. So if we are copying somebody, I showed you the example. So we don't copy it. We have a fundamental, right from beginning we go that. I'm chairman for the recruitment board. When I sit and ask from younger engineer the queries, it is very, very fundamental from 11th, 12th, BE, first year, second year, and third year. So we should have a scratch knowledge.
Thank you, sir. It was wonderful. One question is, what happens to the satellite post the mission?
Oh, yeah. I think one part was missed. Yeah, China is also now globally, everybody is planning to sample return mission. That's why very recently you might have seen that after Chandrayaan 3 job is over, the propulsion module, which is continuously orbiting, is still on the moon. Now they have been brought, they are trying to bring it back to Earth's orbit. So this is all future strategy for sample return mission. Sample, when we go, because of the time paucity, I have not shown many of the experiment, but Chandrayaan 3, when it landed, one of the probe was deployed and gone inside the moon surface and did lot of experiment of the sample. This is called sample in situ experiment. But there can be mission where we can collect the sample, like NASA, ESA, China and Japan, they are doing it. They can collect that sample, and when return mission is coming, they can bring it back and we can do thorough examination about the crust here. So that was part of that. And third question, what you asked is,
so this will also reduce the cost as well as give us more insights into the system.
Yeah, it will give more insight. And you asked that whether what will happen to those satellites which will remain that. So for example, Chandrayaan 2 orbital, still it is working, but after some time it will lose its orbit because slowly there will be disturbance and it will fall down on the planet. Like when the satellite we lose in the Earth's orbit, it will come and reduce the orbit and it will burn within the atmosphere. Or if it is at the altitude of 36,000 kilometers, we push little more and we call it a graveyard orbit. It will go beyond orbit. It will never come back to Earth's atmosphere.
Thank you, sir, for adding this. One more question is, how is ISRO able to manage to complete the mission with lesser cost with such extensive research and experimentation?
Yeah, this is a little complex question now here. Many a times, as and today, when you say globally, this various MNCs and various IT companies, their missions will be few months, 6 months, 1 year mission. But space missions will be of the duration of 8 years, 10 years, 12 years. So the basic challenge is cost runaway. It should not happen that whatever cost was incurred or whatever planned, definitely what we propose to the parliament for approval, we always try to do the escalation cost assessment in the beginning, and per annum whatever cost is there, that we try to incorporate in the beginning itself and try to control within that. I mentioned to you our CA experts are there, financial experts are there, and their job is to monitor our financial expenditures, and they try to guide us how to control the cost. And whenever we are trying to exceed it, sometimes it has happened that we have seen lot of failures in the ground. So we have really did lot of experiment and that has overrun the cost. So sometimes it has happened like inside 3D. And that time, little extra support we ask and we justify why it has happened. Sometimes the kind of purchase we get it from outside, they become little more costly, and company being monopoly in the market in the space nation, that becomes. So for a startup, I mentioned to you here that there is a lot of opportunity, and the Prime Minister has unlocked the potential of a space industry, and lot of startup, lot of industries can come forward to do this product so that monopoly can be broken, cost can come down, and everything will be available within country. Thank you.
Thank you, sir. One more, that as moon is moving away from Earth every year, will it affect water bodies on Earth?
My voice was breaking. I couldn't pick up last spell.
Okay, so the question is, as moon is moving away from Earth every year, will it affect water bodies present on Earth?
Oh, that's really nice. Yeah, I think this is very true, because not only that, our body, human body, has lot of water content. And remember, the tides which comes in the sea is very much influenced by the moons. That's why the Amavas and Purnima, we have different effect. And not only that, human body has a mood swing. And people have, psychologists have correlated that it's because of the moon's variation of the dawn and dusk. So here I would like to mention to you, it's very correct. Your observation is very true. And this is going to happen. But remember, it's not 1 or 2 days. It's going to take millions of years. You know, Earth would not have been there if moon would not have been there. Moon today is very calm and quiet. But those were the time when lot of meteorites impact used to be there on the moon. That's why you have seen so many craters on the moon surface. All those would have been directly on Earth's surface. So our Earth's fate would have been anything else. So it's going away, away and away from us, but it will take millions of years. Now moon is quite calm and quiet, and meteorites impact is very less. So it's going to take time, and your observation is perfectly all right. It's going to take a lot of time.
Thank you, sir. So one question that, is there any tour arranged for ISRO? So for school students or group of families allowed?
Very much allowed. And anybody who is interested to visit our space centers like Bangalore for the satellite making, scientific instrument making, space application center, Ahmedabad. We have a launch port in Sriharikota. There you can visit for the launch rockets and that thing. Vikram Sarabhai Space Center, Trivandrum. Any school in the group of students along with the faculty, they can write to ISRO HRD office, and then they can provide the visit time and slot, because every day thousands of students are going to various ISRO center across the country to monitor, to see, to learn from space missions.
Thank you, sir. So what is the procedure or email ID that we can write for?
You can go to the ISRO website. You can find that HRD website, that mail ID, and don't be afraid. You can even write directly to ISRO chairman. He's a very gentle to the core. Our center directors. That's why I was mentioning to you that autonomy within the center, within the ISRO is so high that if Somnath sir, if you see outside, you won't find that he's such a great scientist. So they are so humble, so down to earth. You can directly write to him. So you can write to any center's email ID is given. There is a project planning and evaluation group in each center, PPG we call it. You write to their email ID and they'll respond it without failure.
Thank you, sir. One more question is coming, that you have a 7,000 to 7,500 team. So how you manage the coordination between the team?
Yeah, this is what I told you, mentioned in my this thing also, teamwork, that to spread across the country, not only across the country, our ground stations are across the globe, because satellite will be sometimes visible on Earth side, Sometimes it will not be on the other side, it will be on the other side of the earth. You might have seen the movie Parmanu. When we wanted to have the nuclear explosion, this NASA and USA was trying to monitor to us. So then the visibility of Indian satellite was for a limited time. So we have scientists and engineers across the globe also. So we have a very good communication with each other. They write to us. We have a good review mechanism. We have a team building effort. We have a mechanism where we can have a conference meetings, open meetings. I'm mentioning to you, if you attend ISRO's meeting, you will feel that these people are shouting or fighting so much, but the next moment you come out of the meeting hall, they'll be chit-chatting as if nothing has happened inside the room. So this is the kind of vocal, and this is how our former President Abdul Kalam sir has written in the book Wings of Fires also, the same event that ISRO has the culture. And that's why I told that we don't discriminate, like that monkeys experiment in the management. We don't discriminate between scientists, engineers based on their age group. We only differentiate based on their expertise, knowledge, and capability. Thank you.
Thank you, sir. It was wonderful. So many great learnings today. And the questions are never ending. So can you share your email ID with our audience? Somebody is asking.
Yeah, sure. I think, let me just see that whether I can write it. Anyway, I can spell out my mail ID is SHRI.
Yes, sir. SHRI.
ALOK, Shri Alok, ALOK at yahoo.com.
ALOK
at yahoo.com. So you can write to me. I'll try to answer any of the query in best of my capabilities. I cannot assure that everything is within my reach, but if any query is there which I need to explain to you in little more detail, we can have some 5-minute, 10-minute session sometime later. And also I try to get answer from the field expert and try to answer it. Thank you.
Thank you, sir. One last, how can someone become a scientist with ISRO?
By fundamental knowledge, by determination, and for dedication to join that. I'm sure that by a strong technical background and urge to learn right from the day one till the last day of their retirement, if they have urge to learn, ISRO is the best place.
Thank you, sir. There are many gratitude messages for you. So thank you, sir, from the deepest of our heart. And thank you for the lovely audience we have today. So looking forward to have you at another Saturday next week with Kunal Devmani, who is going to talk about presentation skills.
Thank you.
Thank you, everyone, for joining in, and thank you so much, sir.
Thank you so much.
We are very indebted to you.
Thank you so much for giving this opportunity. Thank you all the members joined in the SOS group. Thank you so much. All the best for the nice 10 days ahead. Thank you.
Thank you. Thank you.
Thank you, sir. Jai Hind.
Jai Hind.